Okay, hello everybody. Just adjust this so that I don't deafen you all with my breathing. There we go. So I'm Jez. This is Software's 7 Deadly Wastes. This, you're probably very aware, is just after lunch, and I had one of those bowls of chili for lunch, and then the guy brought me another one because he seemed to have a hard time shifting it. So I'm kind of full of chili, and I thought I'd really like a beer to go with this chili, but I thought I'd better not have a beer. But it's made me quite sleepy. Sorry, hold on. It really bugs me, that crackly noise. It's made me quite sleepy, so there's a chance that you're all very sleepy as well. You know, I have all this talking energy excitement waking me up, but I've included a game so we can play a game, and maybe that will keep us all awake. So more on the game to come. Did somebody say they can't understand me? Okay, well, there? How's that? Can you hear me now? Okay, that's better. I'm not used to this kind of show business. So what I was saying in those muffled tones was there's a game coming up, and we'll play a game, and it'll keep you awake. So I'm Jez. I try to describe myself as a consultant. I basically help software teams to deliver whatever they need to deliver as quickly as they possibly can. Before I did that, I was a developer for a few years, and then I did some DevOps. I kind of pretended to know what I was doing, and some agile coaching and stuff. And I blog about some of that stuff on Medium, and you can follow me on Twitter if you want to as well, and say nice things. So in the course of sort of trying to help teams to go faster and to deliver faster, I came across this concept of the 7 deadly wastes. So if you were going to answer this question, what slows you down, you'd probably have loads of answers. Anyone could say, our build server is really slow, or I'm going to fiddle with this again. I don't know. Can you hear me now? Yeah? Yeah, but if I go, no, that's no good. Shall I try it with that one? Okay. Okay, how's this? Better. Okay, there we go. And then I can just I can breathe away from it. So if I was going to ask you what slows you down, you'd probably have loads of answers. You'd probably say things like, our build server is really slow, and it takes us 25 minutes to produce a build, and then maybe the tests fail, and then it takes us another 25 minutes once we fix them. Or maybe, you know, deploys take ages, or things like that. Maybe your code is just really complicated, you've got a lot of technical debt, and that's kind of slowing you down. But instead of all that stuff, which is quite specific, I wanted to talk about underlying stuff, the kind of themes around that stuff. And that comes from this Japanese word. I don't speak Japanese, but I think it's pronounced murder. If anybody in the room speaks Japanese, have at it. It means futility. It means kind of uselessness or wastefulness. Shorthand, we can call it waste. And it's part of the Toyota production system. And the Toyota production system, I think it says in the guide for this talk, in the program, that it was invented at the turn of the 20th century. That's a lie, I'm sorry, I lied. It's the middle of the 20th century because nobody was doing mass car manufacture in the turn of the 20th century. So it was the middle of the 20th century, kind of late 1940s through to the 1970s, when it was kind of grew out of Japan and it became known as lean manufacturing. A lot of American car manufacturers picked it up and kind of learned the lessons of it. And some parts of it are quite famous. You might know about things like just-in-time delivery, which is where the guy who screws the wheels onto your car or whatever, he has a big pile of wheels, but his pile of wheels has only got 4 in it. And then by the time he's finished fitting the 4th wheel, he turns around and there's another 4 wheels. So he's not having to kind of scramble about through piles and piles of wheels. He's just got it just there, where he needs it, right on time. So that's manufacturing, right? We're not building cars, though. We're building software for the most part. And this isn't a new concept of software. It was first applied to software probably a few years ago. I don't know if you Google around for it, you'll find lots of people talking about it. But it's not that well known. So I thought we'd look at it as applied to software. So often the solutions to reducing our instances of these wastes are kind of best practices that we know about already. They're things like continuous integration. They're things like automated deploys, or they're, I don't know, other kind of best practices, good architecture. And you've probably heard of most of those already. But the hope is that by identifying these wastes and identifying how they apply to these wastes, you can kind of understand, well, why is continuous integration a useful thing? And why is it more important that we do that now versus do something else now? So let's have a go. I said there was a game to wake us up. The game is, I've used popular Hollywood movies to illustrate each of the wastes. If you know the movie, buzz, however you see fit to buzz, and tell us the movie. So, the first one is this. Does anybody know the movie? It's a bit... Transporter, yep, very good. Thank you. Shout, don't be shy. Transporter, so the waste is transport. And transport is the movement of work. So if you're handing something over from a team of developers, say, to a team of QA people, that's a really common one. You're moving the work from one area of responsibility into another. You're saying, okay, I've done with it, now you go and look at it. This comes from manufacturing, as I said, and it's more obvious in manufacture. It's basically, oh, our factory is across 2 sites, so we have to move a half-finished car down the road. That's obviously a pain, right? And we don't want to do that. With software, it's a little bit more abstract. So it's handovers between teams. It could be things like moving code between branches and between environments. Anything where you kind of go, oh yeah, I think it's his problem now. And then he goes, oh yeah, I think actually you're not done yet. So back in your court. And you kind of end up playing tennis with each other and going, no, off you go, you deal with it. And moving stuff around like that. So that's transport waste. And this is easy, right? We know how to fix this. This is, we just sit our testers somewhere near our developers instead of outsourcing our test team, if we're lucky enough to get away with being able to do that. And then instead of bouncing it between different teams, we can just have a conversation. And that reduces the transport because we only move it over when we both agree, yeah, okay, it's ready for the next phase. We can use continuous integration, so if we integrate the code more often, then we don't have as many long-lived branches. We don't have to chop stuff around. We don't have to go, oh, I'll just cherry-pick that and move it over here. So that's useful. And generally automation. So deployments are transport, effectively. If you can reduce the cost of your deployments through automation, you reduce your transport waste. So that's the first one. It's movie time again. Raiders of the Lost Ark. Top points to whoever said Raiders of the Lost Ark and not Indiana Jones, because in the original cinematic release it was titled Raiders of the Lost Ark. So Raiders of the Lost Ark, in that box is the Ark of the Covenant, and the Ark of the Covenant is being stored and it's being looked after by top men, and it's become part of an inventory. So our next waste is inventory. And inventory, very simply, is undelivered work. So undelivered work is stuff that's abandoned. If you have something kind of knocking around going, oh, I'll get to that one day. Or somebody says to you, oh, stop working on that thing. It's not important anymore. This thing's more important, so start doing this thing. Well, then you have a thing that's just sort of orphaned. It's just lying around. And it's taking up space. And it's therefore inventory. Not only that, the thing you're actually working on right now is inventory. It's work in progress. So that means it isn't done. And if it's not done, then it's not in front of your customers. And if it's not in front of your customers, then it's not creating any value for you. So according to the smart guys at Toyota, it's waste, right? What's the point in it? There's no value. So that only gets worse if you start working on more than one thing at once, because then you have 2 or 3 or 4 or 5 different things that are just kind of knocking around and not producing any value. And actually there's a mathematical law behind all this, mathematical principle, which is called Little's law. And Little's law says, roughly, the less stuff we have in progress at any given time, the faster we will deliver each thing. I'm not going to go into the maths of it. It's actually a fairly simple, x times y equals z kind of equation. But it's kind of weird to get your head around. But basically, it's true. Believe me, maths proves this. So the best way you can avoid having too much inventory is reducing your lead time. Because if you can deliver something the very same day you start it, then it doesn't have a chance to become less important. You don't have a chance for it to hang around for too long. You don't have a chance to get distracted by something else. So things like feature toggles. So I can deliver it today, and then somebody else can worry about switching it on when the business is ready for it. Breaking stuff down into really small deliverable units. We all say, oh yeah, we need to break our stories down much more. It's really important that we break things down smaller and smaller and smaller. This is why, really, because it means that we can ship it quickly and it's not hanging around and it's not there for waste. There's also a technique called branch by abstraction, which it's probably a whole conference talk in its own right. But if you're doing something really big and complicated, like changing, say you're using Hibernate to persist stuff, and you don't want to use Hibernate anymore, you want to use whatever the newest great thing is, I don't know. Somebody tell me a object relational mapper. Or just imagine there's a better one, I don't know, I've no idea. If you wanted to change from Hibernate to something else, you would probably say, oh, well, a lot of people would say, I'll create a branch and I'll do all that work on a branch and it'll take ages and eventually it'll be done and I'll drag stuff that everyone else is working in on into line with that as I go. And then at the end of it, I'll integrate it back again and ship it, and then we'll all be living in a better world. Branch by abstraction says, actually, well, what might be easier in the long run is to do a lot of really, really hard work up front and go, what if we had a sort of a layer in between our things that meant that instead of changing everything all at once, we could just say, oh, well, for this part of the application, use one layer, and for the other part of the application, use another layer. And that's hard. It's one of those questions that you can't Google for. There's no Stack Overflow answer that says, oh, for your particular piece of software, which you wrote yourself and is full of legacy and complicated, this is how you would do that. So it's kind of hard stuff. It's stuff you really pay your programmers for. But if you do that up front, then it means you can deliver in small increments again, and you don't have that long-lived thing taking up space. And the other really good way to reduce inventory is just visualize it. So there's a picture of, this is a Kanban board. I don't know, who uses Kanban boards like this? Oh, yeah, a few of you. So this is, each card here represents a piece of work in progress. Now, unless you have a team of 50, I don't know, somebody's working on more than one thing at a time here, right? Because there's about 50 things on that screen that are all in progress all at the same time. Nobody's capable of working on that many things all at once. So that means it's a clear indication that you have waste, right? How long has that card there been sitting there? Maybe days and days and days. So that's a really useful tool for kind of showing you where you have this problem. But obviously, if you do have a team of 50, that might be absolutely fine. And there was a sort of mantra on the previous screen, which is stop starting, start finishing. Basically, just don't do stuff until you've finished some other stuff. Okay, next film. It's quite an easy film. Forrest Gump. There he goes. And Forrest is running like he likes, and this represents motion. Motion is the movement of people around the work. Now, this is different to transport, which was where we started, because transport is the movement of work around people. This is people around work. A subtle but important difference. So motion is things like task switching, similar to what I was talking about earlier. If you have to have a meeting at a time when nobody's expecting to have a meeting because some problem comes up, then you're effectively getting all your people. Think of it as manufacturing again. If your production line breaks down because, I don't know, a car wheel falls off. I'm sure cars have bits other than wheels, but wheels are all I can think of. So a wheel falls off and it's rolling down the production line. So all the managers come around and they gather around the production line and they go, what are we going to do? So they've moved themselves, those people, to the site where the work is happening to look at it. And you can kind of think of that, there's kind of similarities in that with software. If you have the kind of product where you work on it for ages and ages and ages, and then you think, okay, we're probably about ready to release something into production, or to, you know, post out our floppy disks, or however we do it these days. You probably have a gathering. You go, okay, we're going to have a meeting. Maybe you call it a go no go meeting or a change approval board or something like that. Effectively, what's happened then is the work has got to a certain point, and then you've gone, right, everybody gather around. Let's look at it. Okay, yes, it's good to go. So you're moving people around work. And that's wasteful, because shipping stuff should be kind of normal. It shouldn't be something exceptional. It shouldn't be something where everybody has to gather around. There's other kind of more obvious things. Hot desking is movement of people, and it's really irritating. I worked at a bank for about 6 months where they had hot desking, and it's just awful. So get rid of hot desks if you have them. And finally, building new environments. If you're building an environment specifically to test some feature or other, then you're effectively moving, in this case, resources around the work. You're kind of gathering up and going, oh, I see, I can't test this properly, so I have to build a new environment around it. So things like that, any kind of irregularity like that where you're all having to gather around and look at the problem, is motion. And Johnny Cash has advice for you about motion. There's Johnny Cash. He says, get rhythm. So if you play Get Rhythm to your developers on a loop constantly, this is not my advice. If you think about things like sprints, sprints are not perfect, they're not for everyone, but they're a form of rhythm, right? They give us, okay, at the start of the sprint, we're all going to decide what we're going to do, and then by the end of the sprint, we expect that we'll have something which we can ship, so we know that at that point, we should be ready to ship it. So that reduces unexpected irregularity. It reduces that kind of having to gather around and go, oh God, what's happening today? Our daily stand-up meetings, they give us rhythm, and they give us a reduction in motion waste, because they mean that we do all of our conversations at the start of the day, and then we can just go and crack on with it. So things like that will reduce motion, because they mean that there's less kind of ad hoc, what are we going to do about this? And there's more kind of, okay, it's this point in the day, it's this point in the sprint, say, or this point in our 6-week-long iteration, whatever it might be. So that helps you reduce motion, as does all the stuff to do with reducing inventory, basically. The next film is slightly harder. Apocalypse Now, very good, 100 points. This is, it's very hard, there's probably a better film for this, but this is Waiting. Because Captain Willard, he's waiting. I think that scene actually only lasts 3 seconds or something, so he's not waiting very long, but he looked like he was waiting to me. So waiting is delays in delivering the work. And waiting should be obvious. We can all experience waiting. So if you're waiting for another team, or if you're waiting for some outside input, you're waiting. So I worked for a time at ARM, who are they make mobile processors, or they design mobile processors. And I was basically moving. It was very complicated. I was doing something with their website basically, and they had a separate team which were in charge of the network. So if I wanted to talk to some external API or something, I had to go to the network team and say, network team, I need to talk to this API. Will you please open a port for me from this server to that server, or this IP address range or whatever? And they would go, oh yeah, we can do that. We're going to do that in our next sprint. So you've told us in plenty of time, so that's not a problem. It'll be done by whatever date. And then I'd go, brilliant. I'm really doing a good job here and getting ahead. And then I'd be almost done, and I'd be typing away and implementing stuff and going, and then I'll just call this API there, and then I would have forgotten something. And then I'd go, there's some other port that I need open, right? So I pick up the phone and I go, oh, network team, a bit sheepish. I'm terribly sorry, can you also open this port? And they go, nope. If you'd asked me yesterday, I would have had time, but we've started a new sprint, so it'll have to be 2 weeks. And then I went, oh, I can't wait 2 weeks, and then you have to go and you go to your project manager. Your project manager's like a big guy, he's quite scary, and he just muscles over and goes, just open that port. And everybody gets really annoyed. So that's waiting. Waiting for your project manager to go and beat somebody up. But you might have other kinds of waiting. I mentioned change approval boards, that's the kind of thing you wait for. Waiting for clarification if you have clients, if you're unlucky enough to do work for customers directly. You often have to wait for them to make their minds up about what they want. Any kind of management approval or any decision. I think I've spent 2 or 3 weeks waiting for a solution architect to choose between WordPress and I don't even know, something else. Something else that was worse, if there is. Anyway, so that's waiting. This is a really hard one. This is a really hard problem to solve because most of the time, if your team is waiting, then you have systemic organizational problems. So like at ARM, where the network team ran 2-week sprints and they didn't line up with my sprints, so I had to effectively decide what I wanted them to do 4 weeks in advance. That's a systemic problem. I can't fix that as a member of the web development team, right? That's hard. If there are people in the room of sufficiently high-level management to get to grips with those problems, then please get to grips with them. But obviously that's a difficult one. So maybe if you need work from an external team, like I did in that case, maybe it's time to say, well, actually, they're part of our team, and let's break things up. Let's change the way we structure ourselves. But as individuals, we can help with this. We can take ownership of things a bit more. If a developer is in a daily stand-up, for example, and they say, oh, I'm waiting for Joe to write me a spec, or I'm waiting for, I don't know, Gary to do something. How many times are you going to say I'm waiting in a daily stand-up? You go to the same stand-up the next day, you're going to say, oh, I'm still waiting. Well, what have you done in the intervening period to fix that? So you really need a culture where you can have your developers or whoever feeling able to go and talk to those people and go, look, I can't really do anything until you answer this question for me or you do this work for me, so can you please help me? Otherwise, you'll quickly end up in a situation where you have inventory, right? Because the natural reaction to, oh, I'm waiting for that, so I'll put it down for a minute and I'll pick up something else. And then you're gonna upset me, if nothing else. So talk to people, ownership of problems. These are systemic problems. They're the kind of problems that organizations have all over the place. And it's really the kind of thing that you fix with sort of digital transformations and agile and all that magic. And it's one of the hard ones. From hard to easy, there's an easy film. Thank you for bothering. That's very good. 100 points to you. So Lord of the Rings, I think Lord of the Rings, The Fellowship of the Ring. Return of the King, thank you. I knew I'd get that wrong. They all look the same to me. Lord of the Rings and Return of the King. Now, this is hard to illustrate. This is where I sort of regretted having this weird movie metaphor. Because this is over-processing. Now, the first film I went for was the first rebooted Star Trek film. Because the first rebooted the J.J. Abrams Star Trek film was full of lens flare, and it was famously kind of full of this ridiculous overused effect. But I thought that was a bit too niche. Overprocessing is basically obsessing over things. So Gollum, he obsesses over the ring. He cleans it, he shines it, he looks at it. It's great. Where we overprocess in software, we work too hard. So we gold plate stuff. We pretend that we're Facebook and we need web scale caching magic. We kind of overthink a feature. Writing libraries instead of operational code is sort of a controversial one, but I'll come to that. So this is a fun pretend book from The Practical Dev, which is a Twitter account, and there's a website which I think is dev.to, where people write about things which are interesting. But this problem does happen a lot, where you go, oh, what I need to do there is I'm doing something computationally expensive, so I'd better cache that. And then you have a cache invalidation problem on your hands, right? And cache invalidation is a hard problem. We know this. So then you have many more problems, and before you realize it, the feature takes 3 times as long to develop as anyone ever knew. There's other kinds of overprocessing. I'm kind of picking on caching a little bit because it's an obvious example to go for. There's plenty of other kinds of things. I went for a job interview some years ago, and as part of the job interview, there was a coding test. So I wrote this beautiful, beautiful code. It was PHP, I think, so beautiful in its own way. And I'd written a function, I can't remember even what it did, say I added up 2 numbers, and it was called add numbers. And I'd written a doc block on it, and I'd written add numbers, adds the numbers, return number. And the guy interviewing me said, why did you waste your time writing that doc block? And I said, because it's more beautiful. And then he said, but the function is called add numbers, and all you've done is repeat yourself in the doc block saying this function called add numbers, just add some numbers. And I think that's a really good point. And it's things like that that are a balance to strike, right? Obviously, you don't need a lengthy description of what a function that adds 2 numbers together does, any more than you really need a function that adds numbers together, I suppose. But it's about striking a balance. And that's what I mean by kind of writing libraries. You're kind of writing it as though you're going to open source your beautiful number adding library. And maybe you are, and if you are, make it beautiful. But if you're not, and there's no need for it, and it's, not going to matter, just ship it, right? Get it out the door. That's my view. Name the film. The Shining. I heard The Shining from the background. Yeah, The Shining. The Shining represents overproduction. So while Jack was writing his book in The Shining, he wrote the same line out over and over and over again. He produced a useless set of features. He basically worked too hard. And he built a feature that nobody needed because he wrote a book that was just the same line over and over again. I wrote a blog post about this a little while ago, and on Medium, where people can highlight passages in the text and it goes green, and then other people can see what they've highlighted. I used the phrase, 64% of software features built are rarely or never used. And then the very next sentence said, this comes from a limited study in 2002 and is probably nonsense. But they didn't highlight that part. They just highlighted the part that said 64% of built software features are rarely or never used. So I feel like it's my duty, every time I can, to just say, look, that's nonsense, probably. But it's a compelling statistic, nonetheless. And it's probably sort of true. I think everybody's probably built something that's not turned out to be that useful. Certainly all my side projects I've ever produced, I imagine. And it's kind of obvious, right? You don't want to produce stuff that's useless because it doesn't have any value. And every feature has a cost. Every feature we produce has to be tested, it has to be integrated, it has to be maintained, it has to be compiled. It adds some complexity, it's a potential point of failure, and it's a potential attack vector. So every single feature we produce has all that kind of baggage attached to it, and if that feature in and of itself is useless, then what the hell's the point in all that baggage? One of the guys at Toyota who pioneered all this stuff was a guy called Tashi Ono, and this was his favourite. He said this one's the most important because exactly that, you know, you might produce all the other wastes in the course of producing this thing that's a waste in the first place. So this is another one of those slightly hard, slightly abstract ones, but fast feedback, product ownership, knowing what you're building, understanding why. Everybody talks about developers wanting to have context and understand why what the feature they're building is useful for the business. It's kind of a common proponent of Agile. Excuse me. And that's kind of why, because at least you've had to explain it to somebody, right? At least then you really know, yeah, it genuinely is useful. But obviously also remove stuff that isn't useful because it has all that cost, right? It has to be compiled, it has to be maintained, it's an attack vector, it's a point of failure. Get rid of it, it's not doing you any good. Dear me. And finally, measure. So if you can get analytics from your software, prove that stuff is being used or prove that it's not being used, that's really useful too. Okay, next, and indeed last, because it's number 7, is an easy one, I think. 100 points on offer for anyone who can. Back to the Future, thank you. The points, they do mean prizes, but the prizes are quite abstract. So this represents defects. The DeLorean is broken again. Defects are working on the work. So they are bugs, basically. And everybody here would probably agree that a bug in production is a bad thing, right? But a bug before production is still a bad thing because you have to work over and again on the same feature. So if I'm building a feature and I code it and I think, yeah, that works, and I commit it and I push it to our build server, and our build server runs a set of automated tests, and one of the tests fails, then I've caught that bug before production. But I've still kind of wasted my time because I've had to go and wait for the build server to come back and say, well, that's failed. If we didn't have continuous integration, that would probably be worse because I'd push the feature and then maybe some tester would come along and it would take longer for me to get that feedback and I would have wasted the tester's time as well. Conversely, if I'd been smart and run my unit tests locally before I committed it, then I'd waste even less time because then I found the bug immediately while working on the work and I haven't had to wait for a build cycle to come back. So the sooner and the earlier in a kind of development pipeline that we can find and fix our bugs, the less waste we have. I tell you, the water they give you, it's not good enough. Right, I'm near the end, so I'll try and survive. I can't remember what I was going to say about it. Bugs in production are bad. So we can fix them. We can avoid that problem with things like automated tests. Like I said, better to run them locally than to run them, wait for them to run on a build server. Better to do both, really. Things like dev prod parity, so our development environment matching our prod environment. Again, this is kind of a common idea from things like DevOps. Here's why it's useful, because it saves us this waste. It saves us waiting before a bug hits production to find out that it's a bug. Continuous integration, we've said lots of times. The other one, a slightly more abstract kind of hand-wavy one, is shared understanding. Shared understanding prevents me from programming in a defect, because I understand how the feature is supposed to work, and so does the product owner, and so does the tester. If we don't have a shared understanding, then the product owner will have an idea, and I will have an idea, and maybe the tester will have an idea. And there might be 3 completely different ideas. So I'll build it, and then the tester will go, well, this doesn't do what I thought it's supposed to do, and then we have to have a conversation, and then we agree, and then maybe it goes to UAT, and the product owner says, no, that isn't what I meant. So obviously that's a waste. So building shared understanding is really important. BDD is a really good way of doing that. There's a couple of techniques there. One is example mapping, which you may have seen, which is where you get index cards and you kind of map out what a feature is supposed to do. If you haven't tried it, Google it. And oopsie as well, which I learned about quite recently. I think is quite a new idea. But it's kind of, if you've ever been annoyed by having to go, as a user of the system, I want to be able to log into the system so that I can log into the system and know the system is a system that I can log into. Oopsie's very good at cutting through that nonsense and just being like, oh, I see, yes, build a login because that's what we want to do. But it gives you a framework in which to do that, which is very sensible and very useful. So all of that will stop defects from occurring, or at least reduce them, right? And reducing the wastes is really all we can hope for in many cases. So, there they all are. There are 7 of them. They're all reasons why a development process slows down. They're all reasons why we can't all be as efficient as we'd like to be. I think there are some key themes that we can take from all of that. So even if all you do is just read this last slide, hopefully it's still useful. So, small things, little and often. Automate everything. I think automation works for almost every one of those. Can be helped by, say, automating your deploys. Work on one thing at a time. Really important for reducing inventory, but also reduces waiting, hopefully. Reduces a few other things. Regular pace. We remember Johnny Cash telling us to get rhythm. Rhythm and a regular pace helps with many of these. Deal with complexity early. Dealing with complexity early means that it doesn't hang around. You don't have long-lived features, basically, because it means you get over the hard part first. And finally, a bit of pragmatism. Ship it, and then make it beautiful, and then ship it again. So that's kind of all of that condensed into, I don't know, 6 bullet points. So that's it. That's the 7 wastes. Disagree with me on Twitter, please. I write a news, sort of like a weekly blog thing called Going Faster. If you go to my website, you can subscribe to that. And some of it has ideas about how you can avoid these kinds of problems and other kinds of problems that slow you down. But otherwise, thank you. And if there are questions, I'll happily take them.
Thank you, Jez. My name is Judith. I'm the curator of this IT management track. And first of all, I have one question. You showed us 7 deadly wastes. Which one is the most important in your eyes?
So I think they all obviously have a problem that they have behind them. And I mentioned Tashi at Toyota. His favorite one was overproduction. Personally, the one that I see the most and that I think is the easiest to fix and is therefore, in my eyes, kind of the most irritating is inventory, because you really just need to be careful about it and think, oh, I should just finish this before I start another. And that actually has hugely detrimental effects, not just in terms of inventory waste, in the sort of obvious sense, but it really screws up an organization a lot if it's kind of churning over on problems for forever and context shifting a lot. So I think inventory is kind of the pet hate.
Thank you. Are there any questions?
Hi. Mostly the points are clear to many developers, but what's interesting me is how did management or decision-making personnel react on this kind of pointing out the points you had?
So when I go to a decision maker and say, you have a tremendous amount of transport waste, here is what you should do, or
let me specify. What I expect is that you took the analogy of production in a factory and made mapping onto our problems. So I imagine that in this way you have some kind of common sense about the problems. And what were the reactions when you had, or did you have those presentations in front of management personalities?
Not so much. I think it depends on the people. But I think if you go to a manager of a team who are struggling to perform, and you say, what we should really do is learn lessons from mid-20th century car manufacture, you get fired quite quickly because it sounds like nonsense, right? So I think you just have to kind of, I use them as more of an underlying kind of framework, and I go, oh, this problem that I observe falls into this waste and this waste, and the one that falls into most is probably the most important one to fix first. And then I try and focus it on sort of the solutions and the pragmatism rather than go too big on the theory, if that makes sense. But hopefully you're enlightened people and you'll appreciate the theory. Oh, I can't hear you. Is that on? Or do you need to be closer to it? Not really, but if you yell, I'll repeat it for the people. I think that's an excellent point. So if you didn't hear the question, it was one of the points that I was raging on about was automating and automate all the things that you can. But the question is that not over-processing? Are you not automating uselessly? And you probably are, and that's a very good point. So what I probably should change that wording to is automate the things that you do often. If you have a process like releasing your code into a production environment, if you have a process like running tests, if you have a process where you have to do some busy work cleaning up a database every couple of months or whatever. Those are the things that I mean when I say automate everything. Obviously, I don't think you should go and automate, I don't know, one-offs. Don't write a macro to make your IDE write your function before you write your function, for example, because that's extreme, right? So yes, a degree of pragmatism, and I think automate the things that you see yourself doing often. I'll change that. Thank you. Any other questions?
I don't see any questions anymore. So thank you, Jez, for your talk. See you again.